Hello students, welcome back to Husky Math. Today we will integrate using trigonometric identities. So in this section we will be using more of trigonometric formulas before integrating. Question number 1. Evaluate integration of sine to the power 7x dx. So here before integrating, let I equals to integration of this sine to the power 7x can be written as sine to the power 6x into sine x dx. So this equals to integration of, let us write sine to the power 6x as sine square x whole to the power 3 into sine x dx. Now as we know that sine square x plus cos square x equals to 1, so here I can write this sine square x as 1 minus cos square x whole cube into sine x dx. Now let us substitute this cos x to be t. So let us put cos x equals to t, and differentiating this both sides with respect to x, I'll get ddx of cos x is minus sine x dx equals to dt. That means sine x dx equals to minus dt. Therefore my integral I will be equal to integration of 1 minus, see there was cos square x, and since my cos x is t, so here I will write t square. So it is t square whole cube, and the value of sine x into dx from here is minus dt. So here it will be minus dt. So my now integral becomes minus integration of, now let us expand this expression using a minus b whole cube, then we will have a cube minus 3a square b plus 3a b square minus b cube dt. So this equals to minus integration of 1 minus 3t square plus 3t to the power 4 minus t to the power 6 dt. Now let us separate the integration, then we will have integration of 1 dt minus 3 is constant, integration of t square dt plus 3 is constant, integration of t to the power 4 dt minus integration of t to the power 6 dt. So this equals to minus integration of dt is t minus integration of t square is t cube over 3 plus 3 into integration of t to the power 4 will be t to the power 5 over 5 minus t to the power 7 by 7 plus constant of integration, and putting back the value of t and opening the bracket with minus, then we will have minus cos x plus this 3 and 3 could cancel, so it will be cos cube of x minus 3 by 5 cos to the power 5x plus 1 by 7 cos to the power 7x plus c. Question 2. Evaluate sine 4x into sine 8x dx. So in this type of questions, we remember one formula from trigonometry, that is 2 sine a sine b equals to cos a minus b minus cos a plus b. So for that, let us multiply and divide with 2 at first. So here I will be equal to 1 by 2 integration of 2 sine 4x sine 8x dx. So the purpose of multiplying and dividing with 2 is to use this particular formula, that is 2 sine a sine b. Now using this formula we can write this equals to 1 by 2 integration of cos of a minus b, that is cos of 4x minus 8x minus cos of 4x plus 8x dx. cos of 4x minus 8x is minus 4x minus cos of 12x dx. And since we know that cos of minus theta is cos theta only, so here it will be cos of 4x only minus cos of 12x dx. Now let us separate the integration of cos 4x dx minus integration of cos 12x dx. So this equals to 1 by 2 into the integral of cos 4x is sin 4x, but we have to divide with the derivative of 4x, that is 4. This we have learned in the previous video that whenever there is a linear polynomial inside a function, then that can be done directly. That is, integration of cos x dx would be sin of x, but we have to divide with the derivative of 4x, and we know that the derivative of 4x is 4. That's why here in denominator there it will be 4 minus integration of cos 12x is first sin 12x, but we have to divide with the derivative of 12x, that is 12 plus c. So here on opening the bracket we will have sin 4x by 8 minus sin 12x by 24 plus c. Question number 3. Integrate cos of x into cos of 2x into cos of 3x dx. So here there are 3 functions getting multiplied, but first we will focus at this 2 functions only, and we will try to use the formula 2 cos a into cos b. For that, let us multiply and divide with 2. Then my integral I will be equal to 1 by 2 integration of 2 cos of x cos of 2x, and let us write cos of 3x separately for a while dx. So using the formula on this particular expression, then we will have 1 by 2 integration of cos of a plus b plus cos of a minus b into cos of 3x dx equals to half into cos of 3x plus cos of x minus 2x is minus x, but cos of minus x will be cos of x only, into cos of 3x dx. Now let us multiply with cos of 3x, cos 3x into cos 3x. Let us write cos 3x into cos 3x plus cos of x into cos of 3x dx. We can also write cos square of 3x and use the appropriate formula here, but since I am using the same formula, so let us continue with the same formula. So now again this is in the form of cos a into cos b, and here also there is cos a into cos b. So here let us multiply and divide with 2 again. So here it will be 1 by 2 into 1 by 2 integration of 2 times cos of 3x plus cos of x into cos of 3x dx. So this equals to 1 over 4 integration of 2 cos 3x into cos 3x plus opening the bracket 2 cos of x into cos of 3x dx. Now let us use the same formula, that is 2 cos a cos b. Then this first term will be cos of a plus b plus cos of a minus b plus evaluating 2 cos a cos b. Here also we will have cos of a plus b plus cos of a minus b dx. See, till now we have not integrated yet. We are just modifying the given function to simplest form. So this equals to 1 by 4 integration of cos 6x plus cos 3x minus 3x is cos 0 and cos 0 is 1 plus cos x plus 3x is 4x, plus cos x minus 3x is minus 2x, but cos of minus 2x is simply cos 2x only, dx. Now let us separate the integration. Then we will have integration of cos 6x dx plus integration of 1 dx plus integration of cos 4x dx plus integration of cos 2x dx equals to 1 over 4. Integration of cos 6x is sin 6x, and dividing with the derivative of 6x, that is 6, plus integration of dx is x, plus integration of cos 4x is sin 4x by 4, plus integration of cos 2x is sin 2x by 2. Now let us rearrange it. Then it will be sin 6x by 24 plus sin 4x by 16 plus sin 2x by 8 plus multiplying 1 by 4 and x at last, then it will be x by 4 plus constant of integration. Let us put it here only. So this is the required answer for this question. Question 4. Evaluate integration of sin x square root of 1 plus cos 2x. So here, before integrating, we have one formula, that is cos of 2x equals to 2 cos square x minus 1, and from that we can write 1 plus cos 2x equals to 2 cos square x. So here, in place of this 1 plus cos 2x, we will be writing 2 cos square x from this particular formula. So therefore my I will be equal to integration of sin x square root of 1 plus cos 2x is 2 cos square x dx. So this equals to integration of sin x. Let us separate the square root, then it will be square root of 2 into square root of cos square x dx. So here is square and this square got cancelled, and since root 2 is constant, so let us take it out. Then we will have integration of sin x into cos x dx. Now let us assume this sin x to be t. So put sin x equals to t, and differentiating both sides with respect to x, then we will have cos x dx equals to dt. Therefore my integral I will be equal to square root of 2 integration of sin x is t, and the value of cos x into dx is dt. So here it will be t dt. So this equals to square root of 2 into integration of t is t square by 2. Putting back the value of t, we will have sin square x plus c. Integrate cos of x over cos of x plus alpha dx. So here note that this alpha is a constant, and we will assume this x plus alpha to be t. So let us put x plus alpha equals to t, and differentiating both sides with respect to x, we will have dtx of x is 1 and dtx of alpha is 0. So on the left hand side we will have 1 only. That's why it will be dx equals to dt. And from here we can write the value of x as t minus alpha. Therefore my integral I will be equal to integration of cos of x, and x is my t minus alpha, divided by cos of t. And since dx is equal to dt, so instead of dx I will write dt. Now let us expand cos of t minus of alpha using the trigonometric formula, that is cos t cos alpha plus sin t sin alpha whole divided by cos t dt. And separating the denominator, we will have cos t cos alpha over cos t plus sin t sin alpha by cos t dt. this implies I equals to, here cos t and cos t got cancelled, so we will have integration of cos alpha plus, and here in the second term as you can see that there is sin t over cos t, so here we can write sin alpha first, and sin over cos is tan t dt. Now let us separate the integral, then we will have integration of cos alpha dt plus integration of sin alpha tan t dt. Here since we are integrating with respect to t and since alpha is constant, so here cos alpha will also be constant, and similarly here sin alpha is constant, so integration of tan t dt. So this equals to cos of alpha, integration of t is t, plus sin alpha, integration of tan t is log of sec of t plus constant of integration. Here you might get confused because integration of tan t can also be written as minus log of cos of t, which is similar to plus log of sec t. So putting back the value of t, we will have x plus alpha into cos alpha plus sin alpha into log of sec of x plus alpha plus c. Question 6. Evaluate integration of dx over square root of 1 minus sin x dx. So let I equals to integration of dx over square root of, see here in place of this 1, let us write sin square theta plus cos square theta. See, in place of theta I am writing x by 2 and there is sin x, so here in place of this sin x, from the sub multiple angles we can write this sin x as 2 sin x by 2 into cos x by 2. So since there is a fraction, so I am writing 1 as sin square x by 2 plus cos square x by 2. So sin x is 2 sin x by 2 into cos x by 2 equals to integration of dx over square root of, now here if you see, then this is in the form of a square plus b square minus 2ab. So this is in the form of a minus b whole square. So here we can write a, which is sin x by 2, minus b, which is cos x by 2 whole square, and here we can cancel this square with the square root. Then we will have I equals to integration of dx over sin x by 2 minus cos x by 2. Now at this step let us multiply and divide with 1 by root 2, 1 by root 2. So here 1 by root 2 and 1 by root 2 will get cancelled and it does not affect the original value. This can be written as 1 by square root of 2 integration of dx over, let us multiply with 1 by root 2 and open the bracket, then we will have sin x by 2 into 1 by root 2 minus cos x by 2 into 1 by root 2 equals to 1 by root 2 integration of dx. See, the purpose of multiplying and dividing with the specific number that is 1 by root 2 is that because we know that sin 45 is also 1 by root 2 and cos 45 is also 1 by root 2. So instead of this 1 by root 2, let us write cos 45. So here it will be sin x by 2 cos 45 minus cos x by 2, and instead of this 1 by root 2, let us write sin 45. So this equals to 1 by root 2 integration of dx over, now this denominator is in the form of sine A cos B minus cos A sine B, which is equal to sine A minus B, equals to 1 by root 2 integration of 1 by sine is cosec. So here we will write cosec x by 2 minus pi by 4 dx. And since the integration of cosec x dx is equal to log of tan x by 2, so this equals to 1 by root 2 integration of cos x, and here if you note that this is a linear polynomial because the power of x is 1. So here we can directly write log of tan of x by 2, that is this whole thing is my x by 2. But since that was a linear polynomial, we have to divide this integral with the derivative of this also. And if I differentiate this x by 2 minus pi by 4, then ddx of x by 2 is 1 by 2 and ddx of pi by 4 is 0. So the derivative of this expression is 1 by 2, which we have to divide here, plus c. So ultimately this will be equal to 1 by root 2 into this 1 by 2 becomes 2 into log of tan of x by 2 minus pi by 4 whole divided by 2 will be x by 4 minus pi by 8 plus c. So here if I simplify this 1 by root 2 into 2 by rationalizing, then we will have root 2 log of tan of x by 4 minus pi over 8 plus c. Question number 7. Evaluate dx over 4 cos x plus 3 sin x. So here in this type of questions, we will assume this number 4, which is with cos x, as r sin theta, and the number which is with sin, that is 3, to be r cos theta. On doing so, let us divide r sin theta divided by r cos theta, then this will be equal to 4 by 3. So here r and r got cancelled, and sin over cos is tan theta equals to 4 by 3. So from here the value of theta is tan inverse of 4 by 3, and in order to find the value of r, let us square these two equations and add. So squaring the first equation, we will have 16 equals to r square sin square theta, and squaring the second equation, we will get 9 equals to r square cos square theta. Now let us add these two equations. So adding these two equations, we will have 16 plus 9 equals to r square sin square theta plus r square cos square theta. So this implies 25 equals to r square is common, then we will have sin square theta plus cos square theta, which will be equal to 1. Hence the value of r square from here we got is 25, from which we will get the value of r as 5. So we will take the positive 5 only. So we will be requiring the value of theta and r. Now my integral I will be equal to integration of dx over putting the value of 4 as r sin theta into cos x plus putting the value of 3 as r cos theta sin x equals to r is common on both the terms, so we will take out r common, then we will have 1 by r integration of dx over sin theta cos x plus cos theta sin x. So this is in the form of sin a plus b, I equals to 1 by r integration of dx over sine a plus b, that is theta plus x, and this equals to 1 by r integration of 1 by sine is cosec theta plus x dx. As we know, the formula of integration of cosec x dx is equal to log of tan x by 2 plus c. Therefore, the integral of this will be I equals to 1 by r at first log of tan of theta plus x by 2, and we have to divide with the derivative of theta plus x, and since theta plus x was a linear polynomial, that's why we did it directly here, and the derivative of theta plus x is 1, so we have to divide this integral with 1 plus constant of integration. Now let us put back the value of r, that is 1 by r is 1 by 5 into log of tan, first separate the 2, then we will have theta by 2 plus x by 2 plus c. Now let us replace this theta, then we will have 1 by 5 log of tan, theta is tan inverse 4 by 3, so here it will be 1 by 2 tan inverse of 4 by 3 plus x by 2 plus c. So this much in this video. Keep practicing. Bye bye.